Today we're working on 3.3, graphs of quadratic functions. The first thing I want to look at is vertex form. I have it written out on the paper here for us. G of x equals a times the quantity x minus h squared plus k. The different pieces we can see in vertex form is we can pull the vertex out. If it's written in vertex form, the vertex is hk. Notice when you pull out the x value of the vertex, it's going to be the opposite sign of what you see in the problem. And when you pull out the y, it's going to be the sign that it is in the problem. So we'll try a couple of those in a second. But also I want to point out that if your a is positive, your parabola will open upward. If your a is negative, your parabola will open downward. So let's take a look at a couple examples. We're just going to be finding the vertex. Notice they gave me a problem where it is in vertex form, so we can just pull out the vertex. My vertex is going to be 2. Notice it was a negative here. You'll change the sign, so it's going to be a positive 2 and 9. Let's put down one more example, part B. I've got g of x equals negative the quantity x plus 1 squared minus 3 the vertex. Again, look inside the parentheses. My vertex, we're going to change the sign, so it's going to be a negative 1. Notice, it doesn't matter if it's a positive or negative out here. That has nothing to do with what your vertex is going to be. Look inside your parentheses. We'll change the sign. So like I said, negative 1 and then negative 3. Keep the sign in the problem for the y. So if they give it to you in vertex form, very simple to pull out the vertex. But unfortunately, they don't always give it to you in vertex form. They give it to you in standard form. And we've seen standard form before. If you've got a quadratic function and it's of the form f of x equals ax squared plus bx plus c, this is what standard form looks like. Well, they've got a vertex formula. Negative b over 2a, comma, f of negative b over 2a. Notice it's parts of the quadratic formula. The only part of the quadratic formula that's missing is what comes after the plus or minus sign. Okay, so make that similarity, you'll remember it better. Let's take a look at a couple more examples now. Graph the quadratic function. Find the vertex, x-intercepts, if any, sometimes there's not any, axis of symmetry, and the maximum or minimum. And in part A, they give me f of x equals x squared minus 8x plus 12. Okay, well, first things first, let's find the vertex because we've done that in example 1. This time, it's not in vertex form, but check to see what form it's in. See if it's in vertex form or standard form so you know what you're going to pick in order to find the vertex. Okay, we're going to have to use the vertex formula in this one since it's not in vertex form. So x equals negative b. Okay, so my b here is negative 8. So negative 8, or again, just put positive 8 over 2 times my a is 1. And then we'll just simplify it. So we've got 8 divided by 2. So 4 is our x. To find your y, all you have to do is plug whatever you found for x back into the original function. So let's see, we'll get 16 minus 32, so that's negative 16 plus 12, so that's negative 4. Okay, so we've got 4, negative 4 for the vertex. The next couple of items are pretty simple to find, the axis of symmetry and the maximum or minimum. Once you find the vertex, it pretty much tells you those answers. What I like to do first is figure out, well, is the parabola going to open upward or downward? Because that'll kind of help us out. Okay, so looking at my A is positive, so that means my parabola is going to open upward. So I'm just going to draw myself a little sketch of what that would look like. My parabola is going to open upward. Okay, well that's going to tell us if we're going to have a minimum or a maximum. Can I find a maximum? No, it keeps going up, but I can find a minimum. Okay, so in a quadratic function where the a is positive, it opens upward and you'll have a minimum. So what I like to tell students, you might write in your notes, if a is positive, you've got a minimum. And the minimum is always the y of your vertex. That's my vertex right here. So the y value, negative 4, is my minimum. Likewise, if the parabola had opened downward, and you had a negative a, you'd have a maximum, and the y value of the vertex would still be that maximum value. Okay, so the x of your the y of your vertex is your min or your max. Okay, this x part is actually your axis of symmetry. The axis of symmetry cuts your parabola in half. So it's a vertical line, and that vertical line is x equals whatever the x value of your vertex was. Okay, so my axis of symmetry is x equals 4. Well, we've done almost everything before we need to graph it. We should see if there's some x-intercepts in our problem. Okay, well, to find the x-intercepts, remember you plug 0 in for y and find your x. Well, that's just setting our original equation equal to 0. So 0 equals, let's see, what was our problem? X squared minus 8x plus 12. Okay, well, this is kind of a review from the last section. Okay, we need to solve a quadratic equation. Can we factor it? Well, let's find out. In this one, we have a 1 in front, so that means our middle terms are sum, our last terms are product. What two numbers multiply and give me 12? When I add them, I get -8. Okay, well, -6 times -2 gives me a +12. And when I add those two numbers, I get -8. So I found my two factors. I can set them both equal to 0 and solve. Okay, so I found my x-intercepts. One of my x-intercepts is 6, 0, and my other x-intercept is 2, 0. And I'm ready to graph my parabola. Okay, so I like to put the vertex on the graph first because I know that's where it's going to switch directions. So I like to keep track of where the vertex is. So remember, our vertex was 4, -4. So I'm going to go ahead and plot that. Okay, so our vertex was 4, -4. And then I can plot my x-intercepts. So I had 6, 0 and 2, 0. And that's all I need to sketch the graph. Okay? If you want to find a few more points, you can pick some x values and plug them in and find the y value. But as long as you've got your two x-intercepts and your vertex and you sketch it out, that's all I need. Okay? Make sure that you kind of check it when you're done. Was it supposed to open upward? Well, yeah, we had a +a, so the graph should have opened upward. So, check a few things out when you're done. Make sure it makes sense. Okay, let's try one more like that. So they gave me g of x equals negative x squared minus 6x plus 3. Okay, we'll do the same steps as before. This one again is in standard form, so we're going to have to use the vertex formula. But if it had been in vertex form, you could have just pulled the vertex out. But it's in standard form. We're using the vertex formula. So x equals negative b. Well, that'd be -6. So I'm going to go ahead and just put a +6 over 2 times a, so 2 times -1, and simplify. So we get -3 for our x value. And then to find the y, we plug that back into our function. So we've got -3 squared minus 6 times -3 plus 3. Okay, that'll give me a -9 plus 18 plus 3. Okay, so that gives me 12. Okay, so now we can easily write down our axis of symmetry and our maximum or minimum. Remember, the axis of symmetry is going to be x equals whatever the x was in your vertex, so that was -3. In this one, my a is negative, So that means my parabola is going to open downward and I'm going to have a maximum. So we have a maximum in this one. And that maximum is the y value of your vertex. So it's 12. And let's go ahead and just write down our vertex. We didn't officially write it down yet. So it was -3, 12. And all we've got left to find are the x-intercepts. So again, we'll set our equation equal to 0. Okay, I always like to try to factor it first. I already know that this one's not going to be factorable, but let's just start trying to factor it. I like my x squared term to be positive when I try to factor. It just makes factoring easier. So I'm going to factor out a negative to begin with. That's just going to change all of the signs. Okay, now there's a positive 1 in front of my x squared, so that middle number is the sum, and the last number is the product. Can I multiply two numbers and get -3, but then when I add them, I get 6? No, I can't think of any two numbers that do that. So I'm going to have to use the quadratic formula for this one. Okay, so remember your quadratic formula. (b) plus or minus the square root of b squared minus 4ac all over 2a. So I'll just start plugging it in. Okay, and it doesn't matter which one you use right here. They're both going to give you the same answer. I'll go ahead and use the original problem. Okay, so I'm looking at this one when I'm figuring out my b, my a, and my c. Okay, so my b is -6. Well, -6 will be a +6. Okay, then I've got -6 squared. My a is -1. And my c is 3. And my a was -1. Okay, we'll just start simplifying it. So we've got 6 plus or minus the square root of 36. Let's see, that's going to be a +12 all over -2. Okay, and at this point, you could simplify your radical like I showed you in the last section, but we need to graph it. So it's going to be better for us to just have the decimal. So I like to get out my calculator and just plug it in. Remember that you need to do the top first and then divide by the bottom. If you want to put it in your calculator with parentheses, go ahead and do that. I like to just do it top and then just divide by the -2. So you've got two different problems here. You've got 6 plus square root of 48 divided by -2, and you've got 6 minus square root of 48 divided by -2. So I'll just do the plus first. So I've got 6 plus, and I got to press my second x squared button to get the square root, 48 equals, and then I'll divide by the -2. Okay, so I got -6.46. I'm just going to round because we're just putting it on a graph. Okay, so I'm going to put them over here. So one of my x-intercepts is -6.5 approximately. And now I'll go ahead and put the subtraction in. 6 minus the square root of 48, enter, divided by -2, enter, and I get approximately 0.5. It says 0.464 if you can't see it on the screen, but approximately 0.5. Okay, so now I've got my two x-intercepts. I've got everything I need. I'm just going to go ahead and make my graph. Let's see, and I need to go up to a +12 for the vertex. If you want to go up by 2's to make it easier, that's fine. I'm just going to go ahead and put 12 dashes on here. Okay, remember I like to put my vertex on the graph first. That was -312. And then I plot my x-intercepts, so -6.5 and 0.5. Okay, and we're going to end up crossing over the y-axis. So I didn't ask you to find this, but remember, to find the y-intercept, you would plug 0 in for x and find your y. Well, notice if it's in standard form, the y-intercept is going to be your c, because when you plug 0 in, these two terms cancel out. So I've got 3 for my y-intercept. So just so I have an accurate graph here, I'm going to go ahead and plot that point as well. And then connect your points. Okay, and again, check it out. We had a -a, so the graph should have opened downward like we see in our problem. Okay, so try out the homework and let me know if you have any questions.